Welcome to this first session of Advanced Functions. This is section 1.1, Relations and Functions. Let's cover some terminology before we look at some examples. The first two in the list is domain and range. Domain, also known as the abscissa, is the x values in a coordinate plane. The range, or the ordinate, are the y values in the coordinate plane. The pairing of these two numbers constitutes a relation. A relation is a pairing of two items from two sets. A unique type of relation is a function. A function is a relation where each element of the domain is paired with exactly one element in the range. Let's look at some examples. Here's a wind chill factors chart at 20 degrees Fahrenheit. And as you can see, as the wind speed increases, the wind chill goes down. So the temperature actually goes down. And you've recognized this before in the wintertime. However, when we're going to put these numbers together and we're going to formulate relations, domains, and range, we're going to first pair the numbers together because they have a relation. That's a pairing of two items from separate sets. So let's write this as a relation. Remember, we're using set notation, so use brackets on either end, and we will pair the numbers together. 519, 10.3, 15, negative 5, 20, negative 10, 25, negative 15, and 30, negative 18. Now, in writing the domain, we also use set notation. So we have a big bracket, and we will list the numbers in the domain. Remember, the domain are the x values. So our domain would be listed on the left, so that would be our wind speed values. 5, 10, 15, 20, 25, 30. And we would also put our values in the range as well. The range would be the x values on the right, once again using set notation, and listing these numbers. Negative 18, negative 15, negative 10, negative 5, 3, and 19. Now notice I have listed these numbers in ascending order, which means smallest to largest. Typically when you are writing domain and range, that is how you will write set notation. So set notation for domain and range will be largest to smallest or ascending order. So lowest number, smallest number on the left, largest number on the right. So that would be relation, domain, and range. Let's look at another example. Example number 2, the domain is a relation of all consecutive integers between negative 2 and 2. The range is 2 less than twice the domain. So we have to come up with our domain and range. Remember, domain is x. So the domain is all consecutive integers between negative 2 and 2. So negative 2 and 2 are not included. So that means negative 1, 0, and 1. Our equation for this, since we're looking for the range, our domain is, the range is 2 times the domain minus 2. So 2x minus 2, that's our equation. So how do we get our range values? We plug in the x values on the left into the equation on the right. So I'll do the first one for you, which is negative 1. So 2 times negative 1 minus 2. Negative 2 minus 2. So y is equal to negative 4. So when we have an x of negative 1, our y is negative 4. When we have an x of 0, our y, the range, is going to be negative 2. And when our x is 1, our y is going to be 0. So now we need to plot these points so that we can graph them. And they're just going to be individual points on the graph. Negative 1, negative 4 would be right here. 0, negative 2 would be right here. And 1, 0 would be here. Now notice if I were to draw a line, this would be a straight line because we're working with linear equations. It's a x to the 1 value. But we only have the ordered pair. We don't see the numbers in between the points, so we can only plot the points themselves. So that's how you find an x and y chart graph and write an equation from a word problem. In example number 3, we're looking at a relation, which is a set of ordered pairs, and we need to see if this relation is a function. If you look at the top relation with 3 sets of ordered pairs, we can see that each number in the domain, or the x values, map only to one value in the range, which are the y's. So in example number 3, the first one would in fact be a function. The second one, on the other hand, the one at the bottom, notice the number 4. We have the number 4 in the domain, but the number 4 goes to 2 different numbers in the range. Anytime you see this in a relation of numbers, that constitutes not a function. So in the second example, this is not a function because the 4 simultaneously goes to -2 and +2. If you look at the chart or the graph to the right, you will notice that this relation of numbers or points does not pass what we call the vertical line test. In other words, if I draw a vertical line anywhere on this graph, if I hit more than one point on the graph at one time, that violates the function definition, so it's no longer a function. So as you can see, the 2 red dots that correspond to the 2 ordered pairs that are red violates the vertical line test. If I draw a line, it goes through both points at the same time, so it is no longer a function. Example number 4, this is function notation. This will be recited as g of m or g of x, h of x. You always add the of when talking about function notation, and this is how function notation is written. And we want to evaluate these for specific values. In the first one, g of m, our value that we're evaluating this function at is m, even though it's a letter, it doesn't have to be a number. So what does that mean? That means anywhere in the function g of x where we have an x, we're going to place an m there in its place. So the answer to this one would be 2m to the 6th minus 10m to the 4th minus m squared plus 5. However, in the second one, we're not evaluating one variable, we're evaluating a binomial. So we have h of a minus 2. So a minus 2 is going to replace all of the x's in the function. So let's rewrite it. 2 times a minus 2 squared minus a minus 2 plus 3. So now we have some simplification to do. Notice we have a binomial squared, so we're going to FOIL that. So that would be 2 times a squared minus 4a plus 4 minus a plus 2 plus 3. Because notice I changed the sign on the second binomial, the minus a minus 2. Now it's minus a plus 2. Now we have to simplify again, so we're going to distribute 2a squared minus 8a plus 8 minus a plus 2 plus 3. So now, last simplification needed, 2a squared minus 8a, and then we're going to combine the minus 8a with the minus a, so that's going to be a minus 9a. And then we're going to add 8 and 2 and 3, so 8 and 2 and 3 is 13, so it'll be plus 13. So the last part, 2a squared minus 9a plus 13. That would be your answer. And lastly, as you're looking at domains, sometimes the numbers can get you in trouble. For example, f of x on the left, we cannot put any x value into this function. Why? Because remember, one of the things we cannot do is divide by 0. So we can't have a 0 value in the denominator. So how do we determine what the domain is? We take the denominator and we set it equal to 0. So when you solve for x, you have x and x minus 4. The x that was factored out, that's going to be 0, and the x minus 4 is the one we're going to be concerned about. We're going to do x minus 4 equals 0, so x is equal to 4. So what does that tell us then? So two possibilities. X equals 0, which is the number that was factored out, or x equals 4. So either two of these numbers are going to give us a 0 in the denominator. So we can use, in other words, we can use any number in the domain except 4 and 0. So if I plug 4 in or 0 in for x, in f of x, it's going to give us a divide by 0 scenario, and we can't do that. So x equals 0, x equals 4 is excluded. The g of x, we have to look at this scenario here. We have a radicand in the denominator. We cannot find the radical of a negative number. So we can't have a negative number. So we have to take that x minus 4 and put it less than equal to 0, and then see which values we can use for this radical. Solving this for x gives us x is less than equal to 4. So in other words, any x less than 4 is going to give us a negative radical, and we don't want to deal with a negative radical. So how would we write this? The domain of this one would be x such that all x's are greater than 4.